Alrighty. Good afternoon, everyone. Okay, we got the live going. This is going to be Degree to PE's fourth live FE exam prep session. Very excited for today. Just got home from a meeting, so I'm just going to take a little bit of time to set up my iPad and our practice problems. Give people a minute to join. Let me know if you were able to join yesterday and you want to see new practice problems, or if you weren't able to join yesterday and you want to go over yesterday's practice problems together. My little light keeps going out. Let me charge it. Hey everyone, feel free to join on YouTube Live. Let me know if you were here for yesterday's session. If you were, I will do new practice problems, but so I am just here to help you guys. I did take the FE civil exam. I am now a professional engineer. So I've taken both exams and passed. So this is really just to help you guys. If you're taking the FE civil, that's what I took. But if you're taking any other FE exam, we can go over some of those practice problems as well. Again, let me know in the chat if you were able to join yesterday's. If you were here for yesterday, I'll do new practice problems. But if you weren't able to make it yesterday, I'll just go over the same practice problems that I did yesterday. Uh, but thanks for joining, Ivana. Um, Ooh, Prep FE. So for the FE, I just did self-study. I've heard really great things about Prep FE, but I've never taken it myself, so I can't really say. Is that the program you're considering? And if anyone else has any thoughts on it, let Ivana know. But we're live on TikTok, but unfortunately on TikTok, I can't share the screen and the practice problems. So if you're joining on TikTok, make sure you also join on YouTube so you can actually see my screen. There's a little bit of a lag on YouTube Live than there is on TikTok, but it'll all be fine. Oh, okay. Someone else told me about that book. I've never heard of it before, though. Let's see who we have joining. If you're joining today, drop your name and where you're from in the chat so we can all get to know each other. Um, we are all, well, you all are preparing for the FE, so it's probably good to get to know each other. Maybe you all can be study buddies, help each other out. I'm not seeing a lot of people from yesterday's live joining, so I think I'm just gonna go over the same practice problems that I did yesterday, if that's okay with you guys. Hey, Karashi from Sudan. Where are you from, Ivana? And again, join on YouTube Live if you want to actually be able to see my screen. And don't be shy, drop your name, maybe what school you went to, if you're taking the FE exam this semester, if you've taken it before. California, nice. So I'm in Texas, y'all. That's where I'm at. All right. Again, YouTube Live if you actually want to see my screen as I work through practice problems. Um, but I don't want to keep y'all waiting very long. I was just giving some people more time to join. But yeah, we can go ahead and get started. Also, if you've seen any of my posts about going live, you should be able to grab the link where you can submit any practice problems that you want me to work through. So that's through a Google form. I'm gonna check the submissions to see if anyone submitted a practice problem. I don't see anything, but yeah, feel free, y'all. If you want me to go over a specific practice problem, you can submit it at the link in any of those live posts. YouTube Live is where you can actually see my screen as I work through the practice problem. Um, TikTok is great, but it doesn't give me the same, like, I can't share my iPad screen like I can on YouTube. All right, so let me go ahead and start sharing my iPad so we can work through some practice problems. Oh my goodness, this thing always forgets my iPad. I don't know. Oh, wait. Okay, I see it now. I'm transitioning, so you all should be able to see this now, the practice problem. I have 3 practice problems for us today. They're the same as the ones yesterday. So if you weren't able to join yesterday, um, that's fine because we're going to do the exact same ones. I have an engineering economics problem. I have a surveying problem, and I have a fluid mechanics problem. So we're going to hit a couple different subjects. Yesterday I did take the full hour. Today I think I can speed through it a little bit quicker. So if you guys have questions or anything at the end, or you have a practice problem that you want me to do, we can do that. And Chai82 asked in the TikTok live chat, he said the FE is for civil. And there's a few different FE exams that you can take based on your discipline. If you're a civil engineering student, I would recommend that you take the FE Civil, but obviously, if you're an electrical student, you want to take the FE Electrical, or if you're an environmental engineering major, you should take the environmental one. So, yeah, keep dropping your questions in the chat. Those are really good. Hello, at work, whatever practice problems you can do from Florida. Okay, got you. All right, so, oh my goodness, wait. Can you see my screen? Can you guys see my practice problem screen on YouTube? Just want to make sure you guys can see it. Okay, I see it now. All right, so let's dive in. The first practice problem is engineering economics. It says a company is evaluating a project with an initial cost of $20,000 and an annual benefit of $5,000 for 6 years. If the interest rate is 10%, what is the net present worth? So, whose favorite subject is engineering economics? I don't see a lot of responses. But engineering economics, once you understand the basics of it, these should be really easy questions for you on the FE exam. So these are gimmies. So make sure that Lamar said not mine. So yeah, make sure that you understand how to do these problems, understand how to use your reference manual. By the way, if you don't already have the FE reference manual next to you, go ahead and download that off the NCEES website so that you can start using it while you study. Also, make sure you have a calculator and a paper and something to write with, just so you all can follow along. I will be asking you all what you're getting at certain steps of the problem. But yeah, how do you attack an engineering economics problem? So, um, I think it's always good to draw out a timeline and make sure you understand the information the problem is giving you and you understand what the problem is asking for. So I'm going to go ahead and start writing. So the problem is asking us for the net present worth, but let's, through this timeline, let's show what's actually happening. So I'm going to make a tick mark for every year. 3, 4, 5, year 6. And if we purchase the project today, that would be in year 0, right? Year 0. So if we purchase the project today, that would be money leaving our bank account, unfortunately. So that's going to be represented on the bottom side of the graph. The bottom side of the graph, we're going to show negative values. And then if we're earning money from this venture, we're going to draw that information on the top of the graph. So it's saying that after we purchase the project, we earn a benefit of $5,000 per year. So we don't get that $5,000 when we purchase it today, but at the end of year 1, guess what? We have some extra money in our bank account. We're making profits. So in year 1, we make $5,000. Year At the end of year 2, we make another $5,000. Year 3, year 4, year 5, year 6. So the thing about the value of money is that unfortunately it depreciates over time, right? If I give you 10 bucks today, that 10 bucks is not taking you as far as it did in 2000, the year 2000, right? Because money loses value over time due to inflation and all that stuff. So this value of $5,000 per year, if we go to the FE reference manual, which I'm going to do, so I'm just going to stop sharing my iPad screen for a second so I can pull up the handbook. I've been marking my FE handbook up, but let me go back to my iPad. So I'm in the FE handbook right now. And the great thing about the FE exam is that you get this handbook that has a lot of equations that you'll need, all the equations that you'll need basically to solve problems on the exam, and it's searchable. So you can search the PDF. I'm going to go to engineering economics so I can look at the formulas for that. Engineering economics. It literally has its own section. Okay, let me search economics instead. Maybe I'll have better luck. Okay, we're just gonna, why is mine acting funny? Let's see if I can just scroll there. Let's try this again. Engineering economics. Okay. Oh, okay. Gotcha. So once you search the PDF, and again, I did this practice problem yesterday, so sorry you guys are seeing all these markups. I'm going to erase that. Yes. Okay. So if you also have your FE reference manual next to you, make sure you why didn't that erase anything? Okay, well, I think I marked this up in a different application, so it's not letting me erase, but we need to determine the information that we were given from the problem statement. So we were given this $20,000, which is the initial cost, and this value, any value at year 0 is going to be a present worth, is going to represent present worth. That's how much something is valued in today's dollars. So if a value is given to you in year 0, that is a present worth value. And present worth is represented by the letter P. Okay, so let me see if I can toggle back to the handbook without any major issues. Okay, so what's that annual benefit that we were given? What letter, or what is that? So any amount that you're earning or losing each year, that's going to be a uniform amount per interest period. So that $5,000 is a uniform amount per interest period. So that's going to be the letter A. So this $5,000 here, because we earn it every year, it is known as an annual amount. These can be positive or negative, but in this case, we're earning the money back. So it's going to be represented by the letter A. So we have a present worth value, which is P. We have an annual amount value, which is A. The question is asking us to compare these by calculating the net present worth. So again, $5,000 in year 6 does not have the same value as $5,000 in year 1. So we need to figure out if we converted all this money here, all this money right here, into a present worth value, P, if we converted this A value to a P value, we will then compare the two costs by calculating the net present worth. So the net present worth, and feel free if you have any questions, please just drop them in the chat at any time. I want to make sure that you all feel confident and understand what I'm saying. So, yes. So net present worth, NPW, is going to be your positive values in present day minus your negative values, obviously, right? Present worth is everything in today's dollars, present worth. So, positive value is going to be our A value, the uniform annual amount, A, but we need to multiply that by something to convert it to a P value, right? And then we'll subtract our negative value, which is the initial cost. Initial cost. All right. What do we need? How do we convert an annual amount to a present day amount? So again, go back to your FE reference manual. Sorry, I cannot erase this, but it should be clear in your guys's FE handbooks. If you have any questions about where you get that at or how you download it, let me know. But see how this box right here, it says uniform series present worth. So to get P given an A value, so our A value is that $5,000 that we earn each year after we buy the project. To make that into present day dollars, we need to multiply it by this P over A value. Do y'all see that? Does that make sense? And something that a tutoree asked me the other day, he was asking, well, then what is this for? What is this equation for? So once we figure out this, we can just use our interest rate tables to figure out what the factor you're supposed to multiply by. Use the interest rate tables because it's going to take you much less time than actually calculating the factor using this equation right here. Okay? So we need to multiply A by the P over A value using the interest rate we were given and the number of periods. So we need to multiply A, and let me move this to the center so you guys can see it better. Y'all see that? My face is still kind of blocking it. I'm going to move myself over here. Okay, so we just found out using our engineering reference manual, we need to multiply A by the P, okay, P over A value given the interest rate that we were given. And the number of periods. So if you're following along, can someone tell me what the interest rate is for this problem? What's the interest rate? Can anyone tell me? Drop it in the chat. Don't be shy. There are no stupid answers. Just want to make sure you all are following along. So it's 10%, right? That's what we were given in the problem statement. And then what's the number of periods? You can see it on the timeline. You can see it in the practice problem. How many periods are there? 6. Thank you, Ivana. Okay. And then again, we still need to subtract the initial cost. Okay. So we know our interest rate, we know the number of periods. So to figure out what this factor is that we need to multiply A by, the FE reference manual has these really handy dandy interest rate tables. So each interest rate table is for a different interest rate. So this one's 0.5%, this one's 1%. We need to go to the 10% interest rate table. All right, I've already marked it up because I did this practice problem yesterday, but this is the interest rate table for 10%. We're going to go to that first column where it says N. We know N is equal to 6, right? 6 years. We are looking for the P over A factor. What does that give us? So we're going to multiply our A value by 4.3553 to convert it to a present day amount, present worth. Good job, John. All right. So I'm going to go back to the practice problem. And let's see if I can remember that number. So A is $5,000, right? 5,000. And we need to multiply it by 4.3553. But we still need to subtract that 20K that we paid for it, right? Can someone tell me the answer? Anyone? Any guesses? You guys can do it. You're smart. I'm not even gonna pick up my calculator. I know you guys got it. Don't let me down. Anyone have an answer? What do you get? Yes, John, thank you. You get, oh, can't see this anymore. I'm gonna scroll up a little bit. Hopefully you all have what you need. So if you do all this math in your calculator, and make sure you're using an NCEES approved calculator when you're preparing for the FE exam. I personally am using the Texas Instruments 36X Pro. Your calculator is your best friend, okay? Don't be shy. Make sure you use it. Okay, T. Johnson, I see your question. It says, what about if they give semi-quarterly, etc., end value problems? I've done some practice problems for those, but not strongly confident in those types of engineering economics problems. I can definitely put that on the docket for next week so we can work through one. You can also submit practice problems via a Google form that I can share in the chat. Let me give that to you guys. If there are any practice problems you guys want me to go through, I want to go through those. So please let me know if there's anything you guys really need help with and you want to see. See if I can go to my Google Forms so I can drop the link in the chat so you all can submit any practice problems. Oh, wait. Yeah, shorten the URL, copy, and paste. Okay, You should be able to submit practice problems at that link that I just sent. But yeah, that's a great question. We can definitely tackle those in the future. I go live every Wednesday and Thursday from 3 to 4. So that's great. We already have a practice problem for next week. We're going to do a quarterly or semi-annually end value practice problem. All right, so like John said, we have solved this problem though. We get $1,776.50. So what does that mean? So our NPW is $1,776.50. We've solved the problem. But what does that mean? That means if we convert this annual benefit to an amount today, we're going to get 5,000 times 4.3553. If we converted that to today's dollars, we get $21,776.50. That is more than the amount we initially paid for it, which means we earned a profit. It's a profitable project. So that's awesome. If we got a negative value, that means we're losing money in the long term. So important to do these calculations so that you know, like if you ever want to invest in anything, you know, if you'll actually be making a return on your investment or not. So yeah, thank you so much, John, for dropping the answer in the chat. You are a smart guy. But yeah, that's our first practice problem. Now we're going to go on to our second practice problem. And I did this yesterday, so I got to erase. Just give me a second. This one's not going to be very hard. It's a surveying problem. Do y'all remember taking surveying class? Wasn't that so fun? Have you taken surveying yet? It's a very interesting class. We definitely need surveyors. Surveying is very important in the civil industry. So yeah, this will be a good refresher. So I erased everything. I'm going to share my iPad screen again. Let me move my face one more time. She's just always in the way. Actually, I can make her smaller. Okay. There we go. All right, so this surveying problem, it says a line of sight is established between a level instrument and a staff held on a benchmark of an elevation of 100 meters. The back sight reading is 1.5 meters and the foresight reading is on the point that we're interested in is 2.2 meters. What is the elevation of the point of interest? So when I was going through this practice problem with a tutoree of mine, we could not find this specific surveying equation in the handbook. It may be in the transportation engineering section. I just haven't checked yet, but this is a very simple surveying problem. All the formulas you need are right here, but basically what this thing is in the middle, so this is a piece of our surveying equipment. This is our level. So HI represents the elevation of the level. The BM is the benchmark, obviously, and the TP is going to be our point of interest. So, given all the information in the problem, does anyone want to tell us how to kick this off? What we should do first? All the equations that you need are going to be right here. So first we need to figure out the height of our level instrument. So we need to find out what HI is so that we can back calculate what the elevation is of the point of interest. So we're going to do this first problem here. Let's see, Ivana, for semi-annually, do you have to change I or N? It depends on the problem. So hopefully next week when we do a practice problem with that, we'll be able to talk about that a little bit more in depth. All right, so HI, what is that going to be? So we need the elevation of our benchmark, so we need to do BM Yes, John. BM plus BS equals HI. Um, he said that the benchmark, John said the benchmark is at 100. The back site was given in the problem statement as 1.5, which means we're going to get the height of our level at 101.5 meters. All right, so we solved that first equation. Now let's solve the second equation so that we can find the elevation of the point of interest, like the question is asking. Can anyone tell me the answer to that equation, which is HI minus FS equals TP? I really hope my phone doesn't die. If you're on TikTok live, I'm on my phone, so that's 17%. John got it again. Smart man. Okay, 101.5 minus the foresight was given in the problem statement as 2.2. So you should be getting 99.3 like John did. Does anyone have any questions about that? So let me write it here clearly. TP equals 99.3 meters. That is our answer. Thank you so much, John. You're doing a great job. You're like ready to take the FE exam. All righty. If there's no questions about that surveying problem, we can move on to our last problem, which is fluid mechanics. Spooky. So I am a civil engineer and my background is in water. So I like the fluid mechanics and the water resources sections, but if your bachelor's doesn't focus on that, I can see how it could be difficult. Um, I know a lot of people don't like fluid mechanics. So again, I'm just erasing my screen since I did this problem yesterday. And don't want to give y'all all the answers. But yeah, surveying, engineering, economics, those should be the easier problems on the exam. So make sure you guys are very comfortable with those. When it comes to like the physics subjects, the statics, the mechanics of materials, the structural, the construction engineering, those problems are going to take you a longer time. So you want to make sure you're very comfortable with the easy sections so that you can spend more time on the questions that are in some of those more in-depth engineering topics. Right, let me delete that. I hope y'all aren't seeing this. Okay. So I'm going to start sharing my iPad screen again so you guys can see. Let's see. Joyo say, sorry if I'm not pronouncing your name correctly. He said, where do you usually stream? These are great sources of information. So I just stream on TikTok and YouTube live. TikTok is not letting me actually stream my iPad screen because I don't have enough live hours, whatever. But on YouTube, it is letting me actually show my screen. So if you want to actually see me work through the practice problem, you can do that on YouTube. And I go live every Wednesday and Thursday from 3 to 4 p.m. Central Standard Time because I'm in Texas personally. But yeah, share it with your friends. I wanted to pick a time that would work for college students. I know young professionals also take it, uh, but I also do private tutoring if you all think you need a private tutor. So just hit me up on LinkedIn, Instagram, TikTok, YouTube if you want to meet outside of these live sessions. I'm happy to do that for you guys. Okay, so Practice problem number 3. Are you guys ready? Let me move my face one more time so I'm not in the way. And I am very new to streaming. Actually, so I've been working as an engineer for the past 4 years, but decided to start my own thing and help other engineers become engineers. So all of this is new to me. I've tutored people in the past while I was working in industry, but it seems like my tutorees need more time than I'm able to give while I'm working full time as an engineer. So yeah, now I'm tutoring full time, so yeah, just let me know if you need any help. All right, fluid mechanics. This problem says a horizontal pipe carries water at a velocity of 2 meters per second with a pressure of 300 kilopascals. The pipe narrows to half the cross-sectional area. Assuming incompressible frictionless flow, what is the pressure in the smaller section? And it gives us the density of water as being 1,000 kilograms per meter cubed. So, does this problem scare anyone just right off the bat? It's okay if it does. I think after this, you will feel a lot more confident, even if fluid mechanics was not your best subject. Okay, let's dive in. So again, make sure you have your FE reference manual handy because that has basically everything that you need to perform well on the exam. So let's just take a step back and talk about some of the fundamentals of fluid mechanics. So if you have flow, incompressible frictionless flow, pressurized flow through a pipe, something that will always be true is whatever flow rate, and flow rate is denoted by the letter Q. So Q, that stands for flow rate, which is going to be a volume over time. So V is volume over time. Oh my gosh, my face is blocking it again. Okay, let me move that down. Yes, T. Johnson, Bernoulli equation. We're going to get there. We're going to get there. So flow rate is a volume over time. So you'll usually see it in meters cubed per second or feet cubed per second. And again, coming from the public side and working in water and wastewater, you see this all the time. So this is a very basic concept. So flow rate is Q. So no matter what, the flow going through a pipe, no matter if it's at point A or point B, Q is going to be the same. So if Q is 5 feet cubed per second here, it's still, even though the cross-sectional area is smaller at B, it's still going to be 5 feet cubed per second. Q, again, that's a volume over a time, which is the same thing as multiplying area times velocity, right? Because area is going to be something like meters squared or feet squared. And if you multiply it by velocity, which is going to be a length over a time, so like meters over seconds or feet over seconds, if you multiply across, you're going to get some volume over some time. Okay, so Q equals area times velocity. Q at point A is the same as Q at point B. So I'm going to write that as well down here. So Q1 is going to be equal to Q2, which means A1 times V1 is going to be equal to A2 times V2. And this is known as, anyone know? This is the continuity equation. Okay? So, in our problem statement, I'm going to scroll up a little, so I hope you guys have everything that you need. John said fluid and environmental are my weak areas. Okay, good to know. We will definitely hit those. So next week, maybe let's do another engineering economics problem with quarters or semi-annual periods. And then we can also do more fluids and we can do some environmental. That's good to know. Good to know. And again, you guys can submit practice problems at the link that I put in the YouTube live chat. I haven't had anyone submit anything for the last 2 weeks, so be the first person to be featured on D2P's live FE exam study sessions. I'll give you a shout out. Okay, back to the problem. So we have established the continuity equation. Are there any questions about what I've discussed so far before we move on? I know there's a little bit of lag on YouTube, so just waiting a couple seconds. TikTokers, you guys are probably like, why is she pausing so long? Alrighty, so not seeing any questions. We've established the continuity equation. So let's go back to our problem statement. So we were given V1. V1 is 2.0 meters per second. I hope you guys can see that. Okay. We were also given the pressure in the pipe, P1. But then the problem says the pipe narrows to half the cross-sectional area. So what does that mean in terms of our area values? So the problem is letting us know that A1 or A2 is equal to A1 divided by 2. And you can also write this as 1/2 times A1. So now that we know that, we can actually substitute this value for A2 in our continuity equation. So we're going to have, just going to scroll down, guys, so you guys can see. Okay. So if we substitute 1/2 A1 for A2 in the continuity equation, we get A1 times V1 equals 1/2 A1 times V2. Y'all see how I got that? Hope that's making sense to you all. Okay, so if we simplify this equation, the A1s will cancel. If you divide each side by A1, you won't have the area anymore. So this is telling us that because flow has to be the same in the bigger section of pipe and in the smaller section of pipe. So if your area is decreasing, that means your velocity has to increase, right? They're reciprocal. So we're getting V1 equals 1/2 V2. And we know V1 already, right? It's 2 meters per second. Um, so we can solve for V2. Just going to put down here, V1 equals 2 meters per second. We were given that in the problem statement. So now we're just plugging it in so we can solve for V2. And we're going to get what? What is the velocity in the smaller cross section of pipe? Is it faster or slower than in the first section of pipe? Yes, John, it's going to be 4 meters per second. It's going to be higher because to keep the same amount of flow moving in a smaller area, that means that water needs to be going faster. So it's going to be 4 meters per second. Thank you, John. So we have V1. We have V2. V1 equals 2 meters per second. We also know the pressure in the pipe is 300 kPa at that first point. And we know V2 equals 4 meters per second. But the question is asking us to find what the pressure is at that second point. So that's what we're trying to find. We don't know. And like T. Johnson said, we need to use the Bernoulli equation. The Bernoulli equation helps us relate energy to flow. So I'm going to go to the FE reference handbook so we can look at the Bernoulli equation. Again, it's a searchable PDF. Do not try to scroll through. You're going to lose time on the exam. Make sure you're using the searchable function. And again, it's important to practice with your FE handbook next to you so that you get faster. Okay, so this is going to be in the fluid. Actually, I'm just going to type in Bernoulli. I think it'll come up. Bernoulli. All right, and there we have it. Took us straight to the Bernoulli equation. Very handy. I love this handbook. It's so amazing. Okay, so here are Bernoulli equations. The handbook says the Bernoulli equation is derived when the energy equation is applied to one-dimensional flows, assuming no friction losses and that no pump or turbine exists between sections 1 and 2 in the system. And then it gives us these really handy equations. So I'm going to use the second one down here. You guys see that? So we can get into this more at a later date. I also do plan on posting more in-depth videos for each section of the exam. But just for today's sake, it's just a simple FE exam study session. We're just going to run through this really quick. So there's no elevation change between the first point in the pipe and the second point in the pipe. So we actually don't, there will be no Z value basically here. And instead of dividing by rho, if we just multiply, again, rho is fluid density. Let's just multiply this whole equation by rho, and we'll get P2 plus V2 squared divided by 2. But we need a rho in there. So do y'all see that? Okay. Again, there's no Z value because the elevations of both those points are exactly the same. No change there. It's going to be equal to P1 plus, again, rho V1 squared divided by 2. So I'm just going to grab this equation, copy. We're going to go back to the problem. Let's make it black so it's not confusing. Let's make it red, actually. So this is the equation that we're using. This is, like T. Johnson said, the Bernoulli equation. I used to hate the Bernoulli equation, but it is very helpful, especially if you work with pumps and pipes and elevation changes and things like that. Okay, so the Bernoulli equation is going to help us solve for P1, which is what, I mean, P2, which is what we're looking for. All right, so let's start plugging in values. Oh, one more thing. Before we plug in values, for the Bernoulli equation, we're going to need the pressure in terms of pascals, not kilopascals. So this is going to be 300,000 PA, right? Because we're just multiplying it by 1,000, basically. And you need that because for all the units to work out. So kilopascals, I think a pascal is a Newton, a kilojoule. 1 second. What is a pascal? A pascal is, can anyone tell me? Anyone know? And if you're on TikTok live, I am so sorry. My phone is on 10%, so hopefully we finish with the problem before it dies, but no guarantees. A Pascal unit of measurement. It's going to be newtons over meters squared, which is also like kilograms over meters times seconds squared or something like that. But in order for all the units to work out, you need to convert the pressure at point 1, at the first point, to pascals, not kilopascals. That's all I was saying. Okay, But you have all the information that you need. And also the problem statement gives us a row, which is the fluid density, which is 1,000 kilograms per meter cubed. So if you are already working ahead of me, feel free to give me the answer. Otherwise, you're free to plug in the values and see what you get. I'm just going to start writing it down here. So P2 is what we're looking for. Um, P2. P2 plus, we know rho is 1,000. We know V2 is 4, but don't forget to square it, guys. Um, those are little mistakes that can cost you points on the exam. So make sure you square the 4 and you're typing everything correctly on your calculator. Equals 300,000 plus I guess it doesn't matter what color I do. Okay, plus 1,000 times 2. Again, square it. Make sure you square it. And then divide it by 2. If you solve for P2, what are y'all getting? Let me know. John T. Johnson, do y'all have answers? Oops. What are we getting for pressure at the smaller cross-section of pipe? Okay, John, really close. I think you need to subtract a certain value instead of add. You're really close though. And that's probably going to be one of the multiple choice answers on the exam. So very tricky. So we're going to have P2 plus 4 squared is 16,000 divided by 2 is 8,000. Close again. Okay, and then on the right side of the equation, we have 2 squared, that's 4. 4 times 1,000 is 4,000. 4,000 divided by 2 is 2,000. So we have 300,000 plus 2,000, which is going to be 302,000. Nice. Okay, so we need to subtract 8,000 from both sides to get P2. And we're going to end up with P2 equals 302,000 minus 8,000. That's going to be 294,000 pascals. And if the question asks for the pressure in the same value, in the same units that we were given, we just need to convert this to kilopascals. So it'd be 294 kPa as P2. And there's your answer. Does anyone have any questions on that one? See, fluid mechanics is not that scary. So we used the Bernoulli equation. We had a good understanding of the continuity equation. And we got the answer. Okay, so it's 356. Does anyone have any questions? No worries, man. Thank you so much for participating. Everyone's so shy. I just appreciate that you're trying and you're working through the problem. All right. So I did not record today's session just because I did the exact same problems yesterday. So there should be a video already on the Degree to PE YouTube YouTube playlist that is dated from yesterday that has these exact problems. But yeah, it seems like we've had more people join on Thursday. So it seems like okay, Thursday is the day that works best for everyone, but I also do go live on Wednesdays. So yeah, it was a really great meeting you all. You guys are the chattiest group that I've had. So this has been really fun. And now we know what we're going to go over next week. So yeah, excited to help y'all out. Again, feel free to submit any practice problems that you want me to go over in that link that I put in the chat. You guys did a great job today. Good luck studying, and I'll see y'all next week. Bye.